Zurück zu uns an den Helptisch und nur kurz zu erklären. Manjit kommt extra aus England hierher, aus dem Labor von IBM, irgendwo in Schottland, glaube ich. Und wir werden euch jetzt mal gleich mal ein paar anschauliche Präsentationen zeigen, was passieren könnte, wenn ein Notebook mal, sag ich mal, aus ein paar Meter Höhe runterfällt und dann eben halt die Festplatte dann kaputt geht. Ja? Now I'm switching over to English. Listen carefully, but don't do that at home. What we are trying to show you guys out there. Manjit, just show us what you want to present.
Okay. Here are a couple of hard drives I killed about 10 minutes ago. So please do not do this at home unless you have old hard drives. Yeah. What I'm going to show is exactly how we achieve the active protection. In this hard drive here, which is live, I'm just about to pierce the seal.
And it's right connected to your notebook.
That's right. This software is running on this hard drive at this precise moment. What I'm going to do is a couple of quotes, one of which is 85% of data loss can create so much of a problem whereby companies can cease to operate. 85% of data loss done by hard drive crashes, user problems where they have a improper shutdown, power loss, etc. All that leading to corrupt software can lead to a lot of data loss. 85% of data loss that is reported can lead to companies finishing altogether. Now, what we do in order to prevent that is have a accelerometer, a motion detector built into these Thinkpads, which detects motion. Using predictive software, it then is able to deem whether that vibration is serious enough for it to park and be safe, or whether it can just absorb that as a very simple read-write buffer. It's able to accept that as a normal operation.
For explanation, the sensor is not on the hard drive, it's on the main board.
Yes, it's actually a part of the motherboard.
Okay.
The intelligence is on the machine rather than the hard drive. I'll give you an example. Here you have the drive running away quite happily. As you can see, it's seeking and reading and writing and doing exactly as it's meant to do. As soon as I move this, you saw it going straight into this white part of the parking mechanism. I'll do it again. And the reason why it does that is because it is seen that the movement, which has been zero up until now, has been greatly exaggerated. Therefore, it thinks that it's going to land on the floor.
Yeah.
It can react within 300 milliseconds, which is quicker than this notebook would take to fall to the ground.
Okay.
I will show you that as a part of our video here. This video.
There are videos you can show us.
This video shows very well. In fact, there you go. This is done in a test lab.
That's one of your colleagues.
Yes, this gentleman is quite happily about to pick up a screwdriver, and as you can see, he's lost his ThinkPad. There is the readings that you would get from the motion detector, and at this point here, the hard drive mechanism is activated, and it hasn't even left his leg.
Right.
So that has been very effective in absorbing all that shock. You can see how from the readings, the blue and the red, the shock loadings are considerably higher than they were on that's the end of the video. They're considerably higher than they would be from the sensing mechanism. I'll show you exactly why we want to do that. In this video here, you will see what is the result of a head crash. Your head crashes, and it should be coming up very soon.
We have just to wait until the hard drive finds the fire on the hard disk.
Unless, of course, the hard drive has decided that it has attracted some dust.
Ah, okay.
Now, you have to bear in mind, these hard drives all have filters, and they all have exceedingly high
show it into the camera.
Clean room operation.
Yeah.
In fact, let me just do this, just in case we have an issue with the actual player.
Okay, in case we do have it on my computer, so we can show it from there.
Yes, we can show that.
Essentially,
what happens is when you have a head crash, the head physically contacts the platter. when you physically contact the platter, you leave a scratch or an impact of some sort, which then every time the platter comes round and makes further contact with the head, you get further debris, further dust, further problems. In fact, there it is there.
There's the video, which is started over, I think.
Yeah, and you can see how the heads all bounce on each platter. So it's not just a case of a single head crash. You're talking about multiple head crashes. And there's the impact. And every time that platter is coming round, it's creating further problems. Now, as soon as you have one head crash, your data is in jeopardy. It will cease to exist as a storage device in a very short period of time. You have to bear in mind that the platter is spinning around at 4,500 up to 7,200, which equates in reality to the platter having a relative speed to the head of 150 miles an hour or 170 miles an hour.
160 miles per hour?
Yes.
Okay.
And the gap between the head and the platter is so small, it's the equivalent of a 747 flying 1 foot above the ground. So that might give it some perspective. And at those sort of speeds, any kind of movement can be very, very dangerous to the data. On all our notebooks, our machines are actually suspending the hard drive as a part of the physical, normal day-to-day operation. But the active protection system is put in place now in order to move on to the next stage of mobility computing, which is where we, because of wireless LANs and because of GSM, GPRS, we're all going to be mobile with spinning disks. Up until now, we've been mobile, taking our PC from one place, switching it on, working, closing it down or suspending or resuming, which actively parks the head anyway, and then moving it to another location and starting all over again. Now we're in a situation where we are moving live, and unfortunately so is our highly sensitive piece of equipment.
Is there some kind of plans, or are IBM planning to integrate the sensor and all the technique of APS into their desktop computers? You mentioned the mobility. A lot of guys are moving during their working life from one place to another place and taking their desktop computer with them.
Desktops will not really be relevant here, because most of the time when you're going to be moving your desktop, it is going to be unplugged. You're not going to move your physical desktop monitor plus all the cabling, etc., from one location to another, so it would not be really an issue here. It is primarily for mobile devices, which it excels in.
Okay. Manjit, thank you for your impressive demonstration. We will come back later with the questioning and answering round. Also, Stefan will join us back hier, also bleibt einfach dran. Wenn ihr Fragen habt, nochmal ab in den Comments-Bereich des Artikels hineingehen, dort hineinposten, wir werden sie nachher im nächsten Take noch alle beantworten.